welcome to my video. I want to make a device that has a nice keyboard, like a thumb-sized keyboard. Then as big a screen as we can manage, probably an expansion port so we could add sensors or other peripherals. I want it to have good battery life, Wi-Fi, Bluetooth, all that jazz. Maybe even a touch screen, I don't know. So to program it, we're going to make it as easy as possible. Make it run Python, we'll make an app launcher for it, we'll make it so you can share those apps by just sharing Python scripts, and hopefully we'll end up with a really versatile device that could be useful for debugging or programming or testing or whatever, you know, it'll be very extensible, hopefully very cool. Let's get into it. Just like a version of the Eiffel Tower, which has 3 legs instead of 4, we have 3 main components we need to figure out that are going to hoist the rest of this project. And those are the keyboard, the screen, and the brain. Many people building this project would go brain, Raspberry Pi 5. I say no. Brain, PicoVision. The PicoVision is a board from Pimoroni, and it's basically 2 Raspberry Pi Picos glued together. One of them is set up to work as a CPU, and another RP2040 chip is set up to work as a GPU. And this all comes together into driving an HDMI compatible output. Now, a normal Raspberry Pi Pico can drive an HDMI port, but you have to overclock it and it uses most of the RAM on the device. So with this tag team partnership of 2, we can drive the display faster, we can do it at a higher resolution, and we can leave more memory for the CPU to think about other stuff, like animating those little flappy wings. The PicoVision also boots in just a second or 2, it uses way less power than a full Raspberry Pi, and it's programmable in Python, so it's very easy to make little apps for. For our display, I picked a 5-inch 800 by 480 pixel resolution screen from Elecro. That's got HDMI in, so those are going to pair together great. Now let's talk about that keyboard. I went shopping on the internet shopping, and I found this TV remote which had a keyboard that has basically the layout that I want, all the buttons that I want. So with the magic of credit cards, I've now acquired one and we can go and try and break it. My credit card also purchased me the experience of this little plastic. Oh yeah. I didn't see any screws, so I just started jamming at it with this pointy thing, and that paid dividends in the form of a delicious sandwich stack of components. Perhaps the most delicious of which is this rubber keypad, which I would eat if I could digest rubber, but I can't. So I'm going to look at the PCBs. We have 2 of them, one for the TV style remote and one for the keyboard style remote. On the keyboard PCB, we have a chip in here that all the keyboard buttons wired to. We have a capacitor, and then we have a transistor and a resistor. Now I have no idea how this is wired, but if we look up that chip, we can find a reference design in the datasheet for that chip that tells us probably how this TV remote is wired. And what I gleaned was about 14 of the 16 pins on this chip are potentially involved with reading the keyboard state. But we only need to understand this chip to the extent that we understand how the keyboard is wired, because we're going to replace the entire chip with this. This PCB I designed has a perfect spacing to fit on the solder pads that are currently occupied by that chip. So if we remove the chip, we replace it with this, we can then read all those inputs that previously went to the chip and do whatever we want. I'm pretty sure I'm going to destroy something by trying to remove this chip and the other components and then solder this new board in its place, and I don't want to be embarrassed, so I'm going to do it off camera, but I will report back. And there you go. Nothing to be embarrassed about except all my other personal traits and habits. This went down really well. I think my soldering iron was a little hot, so we have these charred bits in there, but I was able to solder it down. Looks good. I also soldered down 2 resistors and this big chip. This bad boy is a GPIO expander. It's going to take the 16 inputs that chip used to read, turn them into an I2C signal, and transmit that over these 4 little wires. So now we don't have to deal with 16 wires in our project or anything. We just have this nice little cable, and this little cable plugs perfectly into the PicoVision. But wait, Billy Mays, there's more. I also 3D printed a shell so we can fit this and see how it feels. Now, it's not perfect. It's hard to get the spacing right because you're like, is the hole too big or too small, or is the spacing between the holes wrong? But most of the buttons feel good. I'll get it more right next time. Let's go turn this into an actual keyboard. Alright, excuse me. Excuse me, I'm trying to do a thing. Thank you, thank you. This device is a dev term. It's an off-the-shelf CyberDeck kit you can just buy and build, which is fun, but it's not as fun as putting in way more effort for something that's probably slightly worse, like we're doing today. Also whipped out this little Trinky from Adafruit. It's basically a Raspberry Pi Pico with that same I2C port, and it runs the same type of code that our PicoVision does, so we can test it on here and then move it over to the PicoVision when we're ready. I used my existing keyboard to write the code for this new keyboard, and you can see that code right here. The code just loops through every pin, pulls it up, checks every other pin to see if there's a signal on on it. If there is, we know a button's pressed. So then I just pressed every button and saw what 2 numbers were the ones that were pressed, and we made this big list, and bada bing, bada boom, bada keyboard. Looks great. Let's keep working on it. Over the next couple weeks, I just kept iterating on this shell design, adding new mounting points for different components, figuring out where things would lay out, that kind of stuff. There's always so much back and forth with this step. I'm always printing stuff, and then I print something 5% different, and then I feel it, and I look at it, I'm like, oh, that's not quite right, and then we just repeat and repeat and repeat. But then we get there. So with this final-ish gray piece and this less final-ish blue piece, if I put them the right direction together, we can get an idea of how the keyboard and the screen are going to lay. And this is pretty close to the final dimensions of this device. But forget about that blue piece for a second. Forget about it. Out of your mind. Look at this gray piece. This bad boy got a lot of good lumps that have been very carefully designed. So all our components will lay in here, and all those components that go in here are these that are here in my hand. In my hand, I have this LiPo battery charging circuit, PicoVision, duh. We have another USB-C breakout, expansion port, power switch, a micro USB breakout, a little prototyping board to help simplify some wiring, and then one of the wires, I don't know why I picked this one. We're going to need a lot more wires than this. Also, why does this footage look so green? I'm going to grab a bunch of male and female 2-pin connectors, the kind you might have on a small battery. I'll grab the LiPo board, solder on one of the male ends, then I'll take that prototyping board and solder on one of the female ends. This prototyping board has 4 rows of 4 connected pins. So I now have 1 row where all the pins are 5 volts, 1 row where they're all ground. So now I'll solder more female connections into those 2 rows, and we'll have a bunch of little connectors that can go to the screen, the PicoVision, the expansion port, and they'll all get power. Next, we'll switch it up by swapping to the switch and soldering a whip onto there. Off camera, I soldered our power pins from our other USB-C breakout to the voltage in pins for this LiPo charger. Now you might be wondering, why do we need 2 USB-C ports? And you're right to wonder, because we don't. But that LiPo board is pretty big, and there's a lot of wires coming off of it, and I was not willing to compromise having my USB-C port come out anywhere except the exact bottom middle of the device. So to do that, I introduced this other, smaller USB-C breakout, which could fit right in the middle and wouldn't hit anything and would be perfect. At this point, I wanted to screw this into the plastic, make sure the wires were the right length and everything like that. However, I grabbed the wrong screw, and I could not get it to screw in. And I kept trying. Like, I kept working at it. And I think at some point, I realized that the screw was the wrong size, but I was like, I don't know where the right size screw is. So I just kept going. And there's 2 minutes of this. There's 2 minutes of my life of me trying to screw a screw into a hole that I know is the wrong size. Look, I'll even speed up the footage. This is 300% speed, and I just keep going. And then at one point, I'm like, okay, I'll take the board away, I'll screw the screw in, but then I do that, and it just strips out the hole because it's the wrong size screw, and I knew that. And then, I love this part, I blamed the screw. I was like, no, it's not that the screw is the wrong size, which I knew. I blamed the screw. I was like, let me get another identical wrong size screw, and that also did not work. And then I just stopped recording. Anyway, using the correct size screw, I mounted our other USB port, the one that'll actually be on the outside. It's only held with 1 screw, but the plastic holds it nice and steady. The power switch goes in this little slot, whichever direction you'd prefer. I picked at random. This gets screwed in with 2 more correctly sized screws. Then we're ready for a quick power test. This flashing LED means it's looking for a battery, which obviously it doesn't have. And then we flip the power switch, we get that green LED lit up. Looks like at least the switch works. I don't know, maybe the power works too. Peeking at our PicoVision, there's 3 pins we want to expand into our expansion port. Those are RX, TX, and 29, which is the only analog to digital converter pin that's free on the PicoVision. The expansion ports we're using actually have 5 pins because we'll also add to that a ground and a 5-volt source. If we pop in one of our expansion boards, you'll see we have this control pin. That's the one that goes to 29. We'll talk more about that when we deal with some software stuff. And the other ones are exactly labeled as they are. I'm actually going to leave this in here so I don't solder them up the wrong way. A quick jump cut later and we have our wires wired up, and then we have, again, another one of these same little power whips going to that same power board, just like everything else that needs power. After that, I plugged our male micro USB port into our female micro USB port on the Pico. Now we have 4 wires on here that we need. 2 of them go to another power whip, and then 2 of them go to... What was that? Two of them go to the outward-facing USB port data pins. After we solder that up, I put on little heat shrink tubing and we shrink it down. I grabbed our dev term and ran ls-usb to list all our USB devices. It did not show up, so I probably wired something wrong. I undid my beautiful heat shrink, checked all the connectivity, and sure enough, I was one pin off. In my defense, this is what I was reading to know what pins on this port go where, okay? I appreciate this person leaving this comment, but that formatting leaves something to be desired. Anyway, second attempt, ls-USB, and there we go. MicroPython board in FS mode. We have USB data. On the screen front, I've reprinted that screen mount, and now the screen will fit perfectly in here, except it's upside down. And there's also support filament in here. And it still won't fit because of all this extra junk on the back, which we have to mutilate off. Going at it with the full frustrated force of someone who's been snipping and cutting and soldering all day, I just kind of go and go and go, and then it's gone. Then we also have this power switch to deal with. I'll just replace that with a wire that does the same thing the switch does without the switching. Now the only nemesis between us and the success we deeply desire is these frickin' screws. Now I'm not going to do this here because it would send metal shards everywhere, but you can imagine it's going to look like this. I'm going to take the Dremel and I'm going to go I'm going to go and it's going to cut through. It's going to go okay, you got that? You got that image in your head? Keep that. I'll be right back. Look, Ma, no screws. Well, look, Ma, sharp, pointy things that resemble screws, but are a lot more dangerous, but are also slightly shorter, so they lay perfectly in my case. You might normally provide power via that micro USB, but we're in the business of little power whips, so I soldered one of those on, little hot glue, glued that bad boy right down. He ain't going nowhere. Alright, done with the top half for the moment. Now, the keyboard. Our prototype was built using through-hole components, which are great for testing, because if you wire something wrong, you can rewire it. But once I knew it worked, I sent away to Next PCB, the amazing PC fabrication partner of this channel, who's always providing amazing services, even though I make a lot of mistakes and have to order a lot of stuff that never makes it on video. Check them out if you need a PCB made. Now, interestingly, these look quite different, but they're exactly the same. It's the same GPIO expander, just in two different packages. That's kind of like the shape of the chip. And these resistors, they're tiny here, they're big over here, and instead of having these wires that go off, I added a stemma QT port. So exactly the same. Don't even have to change the code, but we do have to solder this down, and to do that, I needed another donor remote. A good tip if you want to suck solder off of a PCB is to use one of these SSO2 solder suckers. It's a little spring-loaded thing that goes and it sucks the solder off or whatever you need solder sucked off of. In our case, we have these through holes here. They got a bunch of solder on them. We want to make sure those are flat so when we lay our daughter board, it's not sitting at an angle. We'll remove the transistor and resistor as well by just heating them up and telling them to get out of here. And then for our main big chip, there's various tools to remove this, hot air guns, etc. I don't have those. I got my little red snips. So I just went through, snipped every pin. Eventually, the chip fell off. I made sure not to film that so you couldn't see it. But then we had a nice clean pad for us to go and solder our board to. Now, this might look like a regular sheet of paper with a regular number of sides, but in fact, it is tape with a double number of sides. And with these powerful scissors capable of cutting tin, we are instead going to cut a little bit of our double-sided tape. We'll blurrily stick that tape to our little daughter board and then carefully line it up so our teeth line up with our pins, and we'll go through one by one. Heat them up, solder them down, heat them up, solder them down. That one got too much solder. Don't worry, we got the solder sucker to solve that. And then there we go. Each of these has this really nice, curved pool of solder. They're nowhere near shorting, and that double-sided tape makes it all adhered very strongly. I feel great about this. This is good engineering work. While I tidy up my desk, I want to let y'all know I reached out to Pimoroni, the makers of the PicoVision, and they offered to do a 20% sale on the PicoVision because of this video. So it's a site-wide sale. There's no promo code or anything, but if you're interested in the PicoVision, now is going to be a good time to buy it. It's going to be a good price. They're not paying me to do this, and they didn't even supply the ones I'm using in this video. I paid for those with my cold hard cash. I'll try to put links in the description for like everything I use in this video, from the double-sided paper tape to this PicoVision, and those are all affiliate links, so if you click on those, they help support the channel. But if not, the PicoVision specifically, you can just go to the website. It'll be the same discount, same duration, etc. Anyway, with our desk clean, we can now reclutter it with other crap because we're ready to start screwing this whole thing together. Logically, electronically, I think we're pretty good. It's just a matter of putting this all together and then figuring out the software and some of the polish on the outside. So first up, we'll take our expansion port, which I resoldered with a different type of wire, and that's going to jam in here, and we'll make sure that our expansion card fits in perfectly, and it does. Then we can go and screw this top half to the bottom half as one would logically do. We want to tighten the screws, but not over tighten them because as the name implies, that would be overly tight. Our display will connect to the PicoVision via this very, very flat HDMI cable, but before we can lay that out, we got to plug in all the power things into the things that need power. We'll plug our hacked together micro USB cable into the Pico, and then the Pico lays flat and 3 screws will lock it in place. Now we can make sure we have an SD card in the PicoVision right here by pushing in this slot that looks like I made it for this purpose, but I did not. About this time is a great time to remember that you forgot to put a resistor here, so you got to resolder that off screen. I swapped the wires on the expansion port for prototyping wire that's thick and stiff. This is going to let us route it very carefully so it lays exactly how I want. It took a bit of finagling, but this is going to give us great control to make sure we keep as much free space on that right side as possible. And the reason we need so much space on that right side is because we need an HDMI connector to fit over there. With the HDMI connector in and the expansion wires bent, that DuPont connector serves double duty because it also pushes that flat HDMI nice and snug against the board. Similar to me at the pool with my shirt off, this is looking pretty dense, but it's also looking pretty good. If we had a big old 2200 milliamp hour battery and then our keyboard that we made way back at the beginning, this is going to allow us to boot into the software I've been working on. This is mostly just a reskin of the launcher that came on the PicoVision, but I made it more tailored for this device, added icons, stuff like that. Chunky, man, stop it. You're bringing energy in here we don't need. I'm gonna go work on this software a bit more and I will be back when I have something cool to show. Alright, it looks pretty similar, honestly, but I did a bunch of stuff that you will see in the epic reveal at the end. We can also now click into apps, and when we do that, you can see we have this picture of Chonky in our Chonky app, but this toolbar is still controlled by the launcher, so we could have system information or whatever else there. This system can also control standard shortcuts to like quit out of an app, so we can go back to the launcher and pick a new app if we wanted. I also put a bunch of time into making it easy to make these apps. So let me give you an example. Let's tweak that Chonky app a bit and you can see kind of how the code looks. This is an IDE called Thani. I've connected the PicoVision to my computer via USB. You can see on the top left, we have files on the computer. Bottom left, we have files on the PicoVision. And then we also have a REPL, a shell that we can run commands on the PicoVision if we want it. If we open up the Chonky app, which is just an app to show a picture of Chonky, you can see we have some metadata up at the top for the name and the icon, and then we have this app class. In here, it's pretty self-explanatory. We're just loading an image and rendering it to the screen. Now, let's say we wanted to swap out this image for, say, the thumbnail of a hit YouTube video. Now, this image is very large. It's a megabyte, high resolution, a lot of colors. We need to kind of compress it down to fit on the PicoVision. Now, I know there's some way I can do that compression as a terminal command, but I don't know it from heart. So what am I going to do? Go Google it like a fool? No. I'm going to use the cool new tool, Warp, which if you haven't heard of it, it's a new type of intelligent terminal for your computer, and they happen to be the sponsor of today's video. Warp works just like a regular terminal. I can run commands, I can go to the folder with my image in it, but then here's where I get stuck. But that's okay. I hit Control-I and I go into agent mode, and now I can ask in natural language to convert this image to the right resolution, make it grayscale, and dither it in the way that we need. When I hit enter, Warp quickly generates a command for me, but that's not all. It also explains what it's doing. It explains the arguments to the command that it picked. If it all looks good, I can hit this button, it inserts it into my terminal, I hit enter, and it runs it like any command I had handwritten. We go back to the folder, and there we go. There's our renamed file, resized, recolored, everything we need. I reached out to Warp to see if they wanted to do this sponsorship because I've used the product for months, and I can genuinely recommend it as a useful alternative to a traditional terminal. I use it on my Linux machine, on my Mac, and I use their feature Warp Drive to share scripts between my two computers. And on top of all that, I think it just looks cool. It's a nice piece of software. Warp is free to use, but if you want to try some of the more powerful pro features, you can use the promo code ABE to get 50% off your first 2 months. With our changed image, all we have to do is upload that to the device and then change the file name in our app. And if we hit this play button, it'll actually reload this app. It won't send us out to the launcher or anything like that. So it's a nice, fast, easy, like feedback loop of testing, deploying, testing, deploying. It's not going to happen for this video, but I want to make a bunch of general purpose debugging and testing apps. So if you have ideas, put them in the comments down below. For this video though, I really wanted to build something that plugs into the expansion port to show that whole flow end to end, again, to get your creative juices going so you can tell me what we should build for a follow-up video. So I put together the simplest standalone expansion you could build for this thing. And that is one of those expansion boards plugged into a microcontroller. This one happens to be a Seeed Studio Xiao, and then that has an LED which we can blink on demand. There is something about this that makes me just want to crush it in my hand, but if I crushed it, it would be broken. But it is, it's not stable like this. Don't build your electronics like this, but it is cute. I wanted to talk about this resistor though on the control line. That is half of a voltage divider with the other half, the other resistor, built into our CyberDeck. This allows us to have one configuration value that we tell the host as soon as this gets plugged in. So, for example, this device, this peripheral, could communicate over UART at different speeds, it could communicate over I2C at different speeds, and depending on the value of this resistor, our host knows which one it is. Here's a diagram. It might help you understand what's going on here. But basically, this limits the voltage that goes into that ADC, the analog digital converter. And based on reading that, we can say, hey, this is a UART device expecting this speed, and we can immediately start trying to communicate with it. The same technique is actually used on USB 3 ports. There's resistors that tell it to go into USB 2 mode or tell it to supply a certain amount of power. Now, when developing expansions or debugging other devices, we have this type of expansion. This one just has these little pins that go to wires, that go to clamps, and those clamps go on to whatever we're working on. So in this case, it's a Pico Plus. Again, probably isn't going to make it in this video, but I would love to make like a generic serial terminal so we could hook this up to whatever and debug it. Anyway, with the electronics pretty much done, we can move on to encasing them in their plasticky tomb. You can see this thin gray piece, I call it the hat. This is what's going to actually be visible on the outside. A little bit different texture, a little bit different color, purely aesthetic, but I think it's nice. We have a matching component called the foot hat, which goes on the bottom. A while back, I printed a front panel for this. I had to go clean out some of the support filaments that got stuck in these holes, very satisfying. And then the front was kind of rough, so I gave it a sand with my sanding sponges. And then I saw this interesting effect. As the sanding dust packed in around that logo, it created a nice outline. Now, if I sprayed this with something like the hard coat Mod Podge I use on a lot of my projects, it'll make that dust disappear because the dust is actually the color of the plastic. So I thought, let's do white dust. And what white dust do I have nearby? Not what you're thinking, baking soda. So I packed some baking soda in that crack, and then I sprayed a bunch of hard coat on it. And I thought, this seems weird, right? But this is actually relatively common. People use what's called cyanoconcrete, a mix of super glue and baking soda, to gap fill on projects. You don't normally want to mix food with your electronics, but we're going to make an exception here. And if it ends up weird, I'll just make another faceplate, whatever. With our faceplate dried, modged, and sanded to perfection, I then mounted our keyboard in there, and we're ready to start screwing this thing together, but not before one last tangent. Let me tell you about this screwdriver I got. I've had this for a few videos. It's one of my favorite tools. It's a Connex 2 handle, and it's just great. If you order like a box of screws, sometimes they come with these little Allen wrenches, which are terrible. But like this thing, plus these nice long bits, these nice long bits are perfect. My brother actually came to visit and I showed him this, and then he immediately went and bought both versions of this handle because he loved it so much. It's hard to describe, but it is a uniquely great bit handle. Anyway, screwing this in. There's a bunch of screws that come through the back to the front plate, and then one behind the battery and one over here in this little hole. After that, we take our foot hat, bunch of little black screws fit all around that to hold that nice and snug. And I think with that, we are ready for our epic reveal. Oh God, just don't tell me the screw also doesn't fit. I can't deal with that again. Never mind, we're good, thank goodness. And with that, we are ready for our epic reveal. All right, do not leave yet. A couple housekeeping things to talk about. So I'm calling the launcher that runs this Slime OS. That is immediately open source on GitHub. It is broken. It is janky. What works in this video, what I showed, that works. Everything else probably broken. But if you want to pick up a PicoVision and run that code on it and help me iterate on it, like that would be amazing. The other thing you can help do is post ideas down below, either for expansions or apps or other form factors where this software might work well, so we could make a little desktop or like a ZX Spectrum format device. We can follow up with any of that if this video is popular. And the best way to help this video get popular, like, favorite, subscribe, all that fun stuff. And then I can make another video about this and we'll flesh out all the apps and it'll be really sick. So as always, thank you for watching and I'll see you next time.